video, I will explain you the example 9.4. Here we have to find out the current that is flowing through the 12K ohm resistor. So here we are given with one current source and one voltage source. So using superposition theorem, when we are considering the effect of one source, we have to deactivate the other source. That means if I am considering this current source, I have to short this voltage source, and when I am considering this voltage source, I have to open this current source. So the value of the current source which is given here is 6 milliampere. This is 6 milliampere. So now let us consider the effect of 6 milliampere current source. So here what happens is, now I will short this, then we have to redraw this circuit. This is 6 milliampere. This is the bridge circuit where we have 6K. Here this is 12K. This is 14K. This is 35K. And this is shorted. That means these both points are at equipotential. So here this is the current that is to be found. So if I take this node as A, this one also will be A. Okay. If I consider this as C and this as D. So what happens is, you can see between A and C we have two resistors connected. Between A and D we have two resistors connected. That means 6K and 12K, these are in parallel. 14K and 35K are in parallel. So this one we can write it like this. This is 6 milliampere current source. This is 12K. This is 6K. This is the current that is to be found out. Now we can say that 6 milliampere it is entering here. The same current will flow here. This is also 6 milliamperes. This is 6 milliamperes. That means our 6 milliampere current, it is getting divided between these two branches. So using the current divider rule, I can find out the current that is flowing through 12K ohm resistor. That is I is equal to the total current 6 milliampere into the resistance in the opposite branch, that is 6 kilo ohm, divided by the sum of resistances, which is 6 plus 12 is 18 kilo ohms. So here we are going to get it as 2 milliamperes. So the current I dash, I1 or I dash, this can be written as 2 milliampere. Okay. So now we will take into consideration the effect of 9 volt voltage source. So here we will open this current source. We are left with this 6K, this is 12K, this is 9 volt source, this is 14K, this is 35K, this is 35K. So now we can see these points A and B. If I consider this as A and B, we can say that these two resistors are in series. These two resistors are in series. That means, in series, the voltage it gets divided. The current that is flowing through the series combination will be same, but the voltage will be divided here. So we can divide the voltage 9 volt between these two resistors. So voltage across this 12 kilo ohm resistor will be total voltage into 12K divided by the sum of resistances, that is 18K. So this one will be 6 volts. So the voltage across this is 6 volts. So can we find out the current using the resistance and the voltage? Yes. So now the current I double dash, that is equal to voltage divided by resistance. So 6 divided by 12K. So this is nothing but 0.5 milliampere. So I double dash is 0.5 milliampere. I dash is 2 milliampere. Both are flowing in the same direction. So the net current, it will be the sum of these two. That is 2 milliampere plus 0.5 milliampere. That will be 2.5 milliampere. So the answer will be 2.5 milliampere.